In this video, we will be talking about how we can do the parameterization of PSC girder in the user section mode of CIM.
Now let's go to the user section mode of PSC girder. So this is the PSC girder. It is having a very advanced level of dimensioning. So let us have a look on the bitmap image of the dimensioning marking. So this is the dimension marking which we are gonna perform in the CIM today. So despite of the asymmetric of the section, we will assume that our section is symmetric. So we will just cut down the L and the R part. So we will left with the B2, B2.1, B2.2, B4, 4.1 and 4.2, and the B1 dimension. So we'll have the symmetric dimension on the other side. Same way, we will be having H1 as the top flange thicknesses and H5 as the bottom flange thickness. H3 will be treated as the height of the wave, while H2 and H4 will have the height of the slopy portion. And this slope have further divided into the two parts where the joint at the joint level 1 will be having the H2.1 from the bottom of the top flange to the GL1 will be having the distance of H2.1, and from the same starting point to the GL2 we will be having the dimension of H2.2. Same way, on the bottom side, we will be having the bottom slope covering by the H4, and from the top of the bottom flange to the GL4, we will be having the height of H4.1, and till the GL3, we will be having the height of H4.2. On the other hand, we will be having the wave thicknesses defined as B1. Same way, the B2 will be defined as the top flange width, and the B4 will be defined as the bottom flange width. Same with the configuration of H4.1 and 4.2, we'll be having the B4.1 and B4.2 while defining the horizontal dimensions. And similarly for the H2.1 and 2.2, we will be having the horizontal dimension for the GL1 and GL2 slope points. And all the dimensions will be replicated to the other side. So now let's go back to the CIM. So first of all, we'll define the reference line on each of these vertical location. So let us first define the reference line on the reference location. Now we'll place the reference line on all the locations where the slope is going to change. But we'll place the reference line on the center location. So we'll keep changing the x coordinate to 0 value. So we have successfully defined the reference lines. Now we shall go for the definition of constraints. So first of all, we will define the fixed constraint at the origin location. We'll click on apply button. Now we'll choose the coincident option, and for the each of the reference line, we will be choosing the edges or the vertices behind those reference line. This vertices of user section will be logged with this reference line. So whenever the reference line gets shifted in the vertical direction, automatically these both points will get shift. We'll click on blue plus. Same we will choose this reference line and we'll follow the same procedure. Now let's define vertical constraints as well for these vertical lines so it will remain intact in the vertical direction. Now let's go to the dimension option and we'll assign the dimensioning. First, we will assign the vertical dimensions. So first of all, we will be having the top flange thickness from first reference line to the second reference line. We'll replace the dimension line. Secondly, we will be having H2 starting from the second line to the fifth line. Up to this mark, we are having H2. And starting from second line to the third line, we are having H2.1. And starting from second to the fourth reference line, we are having H2.2. Next, we are having H3 for the wave height. And starting from the bottom of the wave height point to the top of the bottom flange, we are having H4 dimension. And from this point, this reference line to this reference line, we are having H4.1. And again, starting from the second bottommost line to the fourth bottom line, we are having H4.2. And at the bottom, we will be having H5 as the dimension line. Now let's define the horizontal dimensions. So first of all, we will be having the wave thickness. So we'll mark this top wave vertex point, and with reference of the datum location, we'll mark the dimension line for the half wave thickness. Same for the other side. Now let's define the B2 dimension, which is starting from here and ending at this location. Now again, starting from the reference location and ending at the top flange width, we're having the B2 dimension. Now similar to that, let's define from this location to this location, we will be having B2.1. From here to here, we will be having B2.2. Following the same steps. And similarly, in the bottom, we are having B4. So we'll again refer it to the center location. This is B4.1 and this is B4.2. Same way. So we have completed the definition of dimensioning. We have defined B1, B2, including B2.1 and 2.2, B4, including 4.1 and 4.2. Similarly, for the vertical dimensions, we have defined H1 to H5 dimensions, and specifically for the H2, we have defined 2.1 and 2.2, and for H4, we have defined H2.2, H4.1 and H4.2. Now, for defining the parameters, we'll go to the parameter and click on edit option. Since there are a lot of parameters are there, we'll just copy the parameters from the Excel sheet, create the parameters separately, we'll copy it, and we'll click on this first cell and we'll press Ctrl V on the keyboard to paste the parameters. Now we'll click on green tick to save the parameters, and now it's time to link the parameters with the dimensions. So H13 will be treated as B1 along with H14. Now H15 and H16 will be treated as B2. H17 will be treated as the B2.1 and B2.2. H19 and H20 again B2.1 and B2.2. For H21 and H22 we will be having B4, and H23 B4.1, and H24 we will be having B4.2. Same way, B4.1 and B4.2 for the H25 and H26 respectively. For V10 we will be having H1, and for V18 we will be having H5. Now for the V11 we will be having H2. V12 and V13 will go for the 2.1 and 2.2 for the H. And V14 will go for the H3, which is the height of the wave. V15 for the H4, and the subdimensions of H4, 4.1 and 4.2 will be assigned for the V6, V16 and V17. Now we'll click on the green tick. The dimension line got changed from gray color to the orange. It means that the parameterization has been completed. So now let's change some of the parameters. Let's change the wave thickness from 350 meters to, let's say, 200 meters, 200 millimeters. We'll click on blue plus. So it got updated. Same way, we will change the top flange width from 2000 to, let's say, 2500. So it got again it got updated. Now same way, we can change the height of the top flange, which is H1. So let's assign the height as 200 millimeters. So again it got updated, and accordingly the section shifted upwards. Same way for the H5, let's assign the thickness as 100 millimeters. We'll click on green tick. So yeah, again it got updated. So this is how we can easily parameterize the PSCI girders. And same way, we can go for the any other type of cross section like PSC box girders. Now we'll click on the green tick to save and exit the parameterization of PSCI girder.